So the last connective that we use is going to be the biconditional. So we're just going to go right into this. I'm not going to really hammer anything too much about this because it can get a little confusing with the biconditional, and that's not the scope of this course. So if we have the compound statement, so the compound statement P, if and only if Q is denoted as, with that double-headed arrow. So it kind of looks like a conditional, but it's a biconditional, meaning that it goes in both directions. Okay? Sometimes you may see it abbreviated as this. The IFF, and the IFF stands for if and only if. Okay? So this is really all I want you to know about the biconditional statement. It's just how to write it if you see it. All right? But what I'd like to do is I would like us to turn our attention onto this table right here. So give me 1 second because I have it on another page. I'm just going to copy and paste it into our notes. Now this is taken directly from our book. All right, and this is nothing more than just everything that we looked at so far. So we have a negation, not P, and then a common English translation would be not P, or it is not true that P. That's it. Then we have conjunction, disjunction, conditional, and biconditional. So make sure that you know the difference between all these, and obviously their common English translations. Because what we're going to do now is we're just going to go ahead and write a couple of these. All right? So here's our example here. We're going to say P stands for, we'll use my dog Arthur. So he is happy. Q would be, he is a dog. All right. So, like I said, these two statements pertain to my dog Arthur, who is sleeping right behind me right now. And he's completely knocked out, which is really good because he's not barking then. But anyways, what I want to do is write the following symbolic statements in words. So the first one is going to be all right, so we have not, and then you have in parentheses, right? You have in parentheses P and Q. So just like with anything else, okay? We want to make sure that we start with the work like inside of the parentheses. So if you look at the inside, if we look at the inside, this is going to be, he is happy and he is a dog. All right, so that's inside of the parentheses. But now, and I'm going to write this in red, we have this tilde out front. So now the big question is, okay, well, how do we deal with something like that? Okay? So the way that we think about this is that we are negating the entire statement. All right? So which means, and if you think about, remember that like distributive property I talked about? Well, we have to negate both of these sentences or both of these statements. So this is going to be nothing more than just he is not a dog and he is, oh, sorry, I got them backwards. He is not happy and he is not a dog. Sorry about that, just kind of backwards. So that is how we go ahead and we would translate that. Okay? So you can hopefully see now, this gets a little bit more complicated when you start using compound statements versus simple statements that we saw in section 1. All right? That's why I said this section 2 is a big section. All right? There's a lot of things going on here. All right? Let's try part B. We're going to do this one. So this is not P and Q. Well, this is very straightforward. So this would be, he is not a dog, and he is happy. Okay? Part C. All right. Now, part C deals with this. Once again, we have parentheses with a negation outside of it. However, we have the P or Q inside of it. All right? But once again, this symbolic statement means the negation of the entire statement of P or Q. All right? So, he is not a dog, or he is not happy. All right? So, like I said, these are very, very straightforward examples here, okay? You just got to understand like how this works and relate it back to what you've learned in math previously. Okay? But now the question becomes, what if you have more than one connective? So, what if we have more than one connective, which we've seen this already with the examples above? Is there like an order? Okay? And the question to that answer is, yeah, there kind of is an order. All right? So let me go ahead and let me get this. And I'm going to copy and paste this into our notes. All right, and this is nothing more than the dominance of connectives. It's kind of like, okay, when using symbolic logic, is there an order? And yes, this is the order here, all right? Now, the one thing you got to remember is this is not set in stone, all right? But it definitely does help. Because when we go into section 3, which deals with truth tables, we're going to have to navigate our way through this, okay? So, real quick, the least dominant would be the negation. Conjunction and disjunction, they have the same level of dominance. Then your conditional, then the biconditional is the most dominant. All right? We are going to be focusing on mainly the first 3. We don't really have to worry about the biconditional too much. If it happens, it happens. But like I said, I'm not going to worry too much about it. Okay? So let's look at this example here. We're going to let P, Q, and R represent the following simple statements. Okay, P is going to stand for a student misses lecture. Q is going to stand for a student studies. R is going to stand for a student fails. Okay? We're going to just write these out in symbolic notation, or we're going to write the statements in words. For example, here's our first statement here. All right, so the thing to remember here is you want to try to find like I said, these dominant characters, all right, these dominant connectives. So right here, I have this entire compound statement, but notice it's inside of parentheses. So this whole thing is like one big idea, all right? Then on the other side, we have this. Now, if I scrolled up above, notice that the conditional is number 3 in terms of dominance. So this symbol in the middle is our dominant connective. All right? So this is nothing more than an if then statement. The only thing we have to do now is just write it out in words. All right? So now the big question becomes, all right, well, how do you write this stuff out in words if you have like these if you have these parentheses and everything? All right. So let's first, I need these up top so I can just see them. Let's worry about the parentheses first. Let's worry about the antecedent. Okay. So we know in reality, this is going to be if, and then you have the Q statement. So if a student studies, I'm going to write it like this first. So if a student studies and does not miss lecture, then the student does not fail. All right. So that's a pretty strong statement if you think about it. All right. So, and the reason why I left it in parentheses is because I want you to see that this right here, and I'm going to highlight everything. So he student studies. There's your Q. Does not miss lecture. There's your not P. Now you have the word and, which is the conjunction of these two simple statements. With our if out front, comma, then the student does not fail. There's our not R. So that's all I wanted us to do in this example here, was just to learn how to translate simple statements into compound statements, then back into these compound connectives and all this good stuff. All right? So that is going to be it for this video. In the next section, we're going to go over the validity of these statements. All right? So if you went back and you looked at all these examples, notice I never said, well, this is a true statement or this is a false statement. All I said was, we're going to take these statements and convert them into symbols, or we're going to take these symbols and then write them out in words again. Section 3, that's where we start talking about the validity of these statements. But that's next section. So see you in that video. Bye-bye.